two squares, how to factor what I call regular trinomials, trinomials where the quadratic coefficient is 1. We went through most recently on Tuesday, and then again yesterday you watched a video on factoring things like what you see on your screen now, examples where the term has a coefficient other than 1, and that makes it a little bit more challenging. We've talked about factoring where there's 4 terms. What method did we say you use when there's 4 terms? Grouping. Now, somebody mentioned the British method. That's how you would factor a trinomial like this, by making it turn into 4 terms, and therefore using grouping. But we've been learning all these factoring techniques, and you might be asking yourself the question, well, why in the world am I learning all these? Well, our next sort of unit, I guess we could call it, is going to be application of all this stuff. Like, why we bother learning how to factor is so that we can do things like solve equations, answer real-world questions that are modeled by quadratic functions and things like that. So needless to say, this is a basic fundamental skill. If you're not good at factoring, you're not going to enjoy the next 2 months. So get good at factoring, right? And how do we get good at factoring? We ask good questions, we take diligent notes, and we practice, okay? I've got on Delta Math a buttload of assignments that I've been giving to my 9th graders along the way, because they are officially, in my grade book, earning grades, and you guys have been getting those assignments too. I don't know if you've been doing them or not, but we must be practicing. In a normal year, I've got my, well, heck, I got a stack of them right here. I got my textbooks that I would say, hey, do, numbers 1 through 30. You guys have, I'm assuming here, do y'all have textbooks? Some do, all do. You guys have textbooks? St. Louis? Yeah. You guys have textbooks? Find where this stuff is in your textbook and practice. Pick a few of the odd numbered questions. Usually Bob has the answers with him, right? And just practice. That's my little soapbox. We'll get to it now. Paul, you'd asked for another example of the magic method. What's our first step here on this kind of problem? Yeah, we're going to multiply that leading coefficient times that constant term, right? And then I like to say it's as though it magically disappears, and we're going to create an easier problem. Now, this problem in orange is not the same thing as the problem in black. Duh, right? But the trick here is that if I can learn how this one in orange factors, then I can use that result to show me how the one in black factors. This is a very important tenet in algebra and in calculus, is that if I've got a complicated problem and I can simplify it away to an easier, get it down to a core basic example, and I can work this basic example, then I can use the results of that basic example to help me. We do it all the time in our calculus classes, okay? So this is a good illustration of how that works. Quentin, go ahead and tell me what 2 factors of -10 did we set up to add up to a +9? Because I know x is going to begin. Yeah, we got +10 and we got -1. That's easy. That's basic, rudimentary. That's that core, simple example. And then our little technique says, okay, bring the 2 back and then kill off that common factor, because we can't have 2x in the front of both. In that case, we'd have 4x squared. So now we've got x plus 5, 2x minus 1. Paul, that's just another look at that same question right there. And my goal for you guys, I think I said this on Tuesday maybe, is that y'all get pretty proficient to where you could do these rather rapidly. You know what I'm saying? To where it doesn't take more than about a minute to factor one of these out. All right, it's a good question, fabulous question. Anybody else that wanted to ask either about class on Tuesday or yesterday's class that y'all watched via screencast? Jack. Lewis, you can put your hand down. I know you've got a question. I'll get you in just a sec. Jack's got one. Jack, you're going to have to speak up a wee bit. Well, when you say put x squared, like if you were to check your answer, Alex, how do I check my answer? If you were going to FOIL this back out, note what is x times 2x? 2x squared, good. So if I put an x squared here, which I think is what you're asking about, right? if I put an x squared here and here, then when I FOIL that out, x squared times x squared is going to be x to the fourth, which is not what we started with up at the top. However, okay, once in a while, you'll check this out. And then, Lewis, I'll get your question. Was that plus 10 minus 1? All right, so like you might get an example. Let's just put together a basic example. All right, write that example down. Now you might have a case where you say, okay, well, wait a minute. Look at that first term. That first term is x to the fourth, right? So Nate, instead of x and x leading to my two binomials, what's going to be in front of my two binomials? Yeah, x squared and x squared. And again, Quentin had done this for us in the last one. Tiago, do this for me here. What are two factors of negative 10 that add up to positive 9? So 10 and negative, that boy, negative 1. Okay. But I'm throwing a little curveball your way, Charlie. Charlie, can you hit a curveball? Huh? You don't know? Well, we're about to find out. You can't stop right here. This is not the final answer, Charlie. Why not? Still factor it down. Lewis, how, Charlie's correct. How could I factor this down further?
The difference of perfect squares.
Oh, dump. Hold on a second. I feel like I was having this issue on Wednesday with my ninth graders. Uh-oh, hold on. Oh, that's the one I want. Okay. All right, let's get this squared away. Boy, I don't feel like dealing with this all day long. I hope I can get it squared away with you guys. I was having audio issues the other day. Settings. Of course, you boys at home could just be messing with me. You could just be miming the whole deal. All right, display audio. Oh, jackpot. Okay, I think that's what I want. Lewis, can you try again?
Is it the difference of perfect squares?
Yeah, that a boy. I can hear you now. Can you hear me now? Okay. Yeah, the difference of two squares. How does the factoring of the difference of two squares will come about? He's identified x squared minus 1. I can't do anything with x squared plus 10, but what can I do with x squared minus 1?
Do x minus 1, x plus 1.
That a boy. A binomial class times its. Does that daggone look like an R? Conjugate. Did we forget that word? Conjugate. X plus 1, x minus 1. I know Will said x minus 1, x plus 1. Whatever floats your boat, Will. If you're a negative Nelly, that's your deal. I'm a positive Patty. I like to have my positive one come first. But anyway, I'm joking around. Commutative property makes no difference either way. All right, Lewis, you had a question. Go ahead, bub.
What if the coefficient and the constant don't like factor out to the middle number?
Woohoo! What a great question. That did we have one in the video that didn't work? Did I give you guys one like that? Okay, excellent. Okay, so what he's asking, I'm just gonna make one up. Okay, so like 3x squared plus 7x minus 8. Okay. So we're just write this example down. We're just stumbling across this example, okay? And we're assessing things. We're gonna do like a factoring triage, so to speak. You know, if you got somebody that comes into your emergency room and they're in the triage section, that just means we got to figure out what's going on. And we got to figure it out fast. We got to handle the most dire needs first. All right, so that's all about prioritization. So my priorities for factoring are always going to start with GCF. That's bread and butter factoring technique numero uno. Okay, what do I mean by GCF? Is there anything in common with all three of these terms? And you guys would answer me what? No, there's nothing in common. Okay, next thing I look for is how many terms are there, because if there's two terms, it might likely be a difference of two squares. If it's three terms, might likely be either a regular trinomial or one of those special trinomials. If it's four terms, I'm thinking grouping. This one's obviously a trinomial, so I've got magic method on the mind, okay? Now, magic method starts by, and don't I forget who asked this question. Lewis, was this your question? Magic method starts by doing what? Go ahead, Lewis Thomas.
Do you multiply the coefficient and the constant?
Yeah, okay, so like 3 times -8, right, boys? So what would this be? X squared plus 7x minus 24. Okay, now some of you alpha dogs, see my voice, not very strong. I didn't get a good woof woof. Some of you guys might have already looked at this, and in this case, you're looking for two factors of -24 that add up to 7. What are they? Oh, how now, brown cow? If we try and find one, 3 times -8, 4 times -6, 6 times -4, 8 times -3, 12 times -2, 24 times -1. There's not one. Quentin is correct. Okay? So we stop at that point and we say, because the orange one does not factor, the blue one does not factor. Do you guys know that's what DNF stands for? Does not factor. And that's okay. Is everything going to factor in this whole wide world? Heck no. You guys are learning, though, to determine whether or not something does factor by going through the process and by thinking about it just a little bit. So, Lewis, that's a great question, buddy. If you encounter one on the homework or if you encounter one on a test and you think it does not factor, let me warn you, let me caution you, though, just be careful. Okay? Ben, I had a group of ninth graders one time that, let's say I gave them a little factoring quiz, and let's say there was 10 factoring questions on there. Okay, how would you feel, Ben, if you were the teacher and you had a kid turn in a paper and he had written D and F on 8 out of those 10? You think that's very likely? As a teacher, would you make up a test that looked like that? Of course not. That's not the way it works. Guys, D and F is going to show up once in a blue moon. Okay, what that means is not very frequently. Y'all know what a blue moon is. Did we talk about blue moon on Tuesday? Okay, good. So anywho, Lewis, to your question, you would just say does not factor and you'd move on, but don't use that as a cop-out to every little problem that presents you challenges. That's your last resort. Resort. Last resort. All right, what we want to do today is we want to wrap up, as I said in our intro to this class, wrap up and take a look at our very last factoring technique, which I'm going to put on the screen here. Is called a perfect square trinomial. Okay, a perfect square trinomial is our final factoring technique for this lesson. And I start by asking you guys, do y'all know your perfect squares? And goodness, I hope you know the first 12 at least. That's like elementary school. I think Teddy knows those, and he learned them last year in the 3rd grade. My son. But it's very helpful to know all 20. So like when I say, hey, what's 17 squared, knowing that that's 289 is a helpful thing. Not because I'm going to come in, I'm going to say, hey, Drew, quick quiz question, what's 17 squared? No, but I'm going to give a factoring problem, and you might see 289 in there, and recognizing that as, oh, yeah, that's 17 squared is going to make your life a whole heck of a lot easier. You know what I'm saying? So like everybody already knows 1 through 12 squared. If my challenge for you guys is to learn 1 through 20 squared, okay? And that way you can recognize, ooh, perfect square. Now, over on the left in these gray boxes, I call these our templates, okay? You know what a template is? You guys do Word documents? Do y'all have to work with Word on your computer skills? Google Docs. I bet Google Docs has templates. They do? Okay, cool. So like, let me use an example from my life. About a month ago, I wanted to write a letter to all my friends and family, kind of an end of year letter. A lot of times y'all's families might do those too, mail them out in the Christmas cards, right? And so I looked online. I opened up my Word document and I said, I want a family newsletter template. And what it does is it has one already put together like an example, and everything's placeholded, it's spaced out, you got the margins, you got the colors and everything. It looks great. All you do is swap out that stock photo with your photo, swap out that paragraph with whatever you want to say, and the title and so on and so forth. That's a template. All right, somebody has already put it together for you. You just fill in the gaps. In gray, these are our templates for perfect square trinomials, okay? So you're not going to come across a problem that's a squared plus 2ab plus 2b squared. You might come across a problem that's like x squared plus 10x plus 25, okay? And what you're going to do is you're going to determine, okay, well, what is my quote, quote, a value? What's the first thing that's being squared? What's my b value? What's the second thing that's being squared? And actually, that example that I just quoted for you is right down here with example 1, okay? So what we're going to do is we're going to use this template. We're going to note that, oh, when it's a PST, when it's a perfect square trinomial, the result is a binomial squared, a binomial times itself. Okay? Unlike the difference of squares where we said it's a binomial times its conjugate, this is going to be a binomial times itself. Okay? And there's a nice little checklist. See if I can get both of these on the screen so y'all can. There we go. So y'all can do a little bit of note taking. What I like to do is, and heck, I don't make students go through this every time, but it's our first example, so we'll go through it together. I like students to just run through this little checklist, okay? And what this checklist says is it says, hey, is the first term a perfect square? Now let me go ahead and let the cat out of the bag. Anything, any variable raised to an even exponent is a perfect square. I spoke slowly and clearly. I did this little finger thing for emphasis, and I looked you in the eye. What does that mean you should probably be doing right now? Writing that down. Good. Y'all pick up on these little classroom cues pretty quickly, don't you? So like, yeah, anything, any variable raised to an even power is a perfect square. Okay, Moss, did you get that? Anything raised to an even power is a perfect square. So like x to the second would be x times x. X to the fourth would, as we saw earlier, right, is what? X squared times x squared. Andrew, what do you think x to the 100 could split up as?
X to the 10th.
I get that all the time. X to the 10th times x to the 10th would be x to the 20th. So again, what do you think x to the 100 could split up as?
X to the 50th.
That boy. Good. I didn't even have to write that down for you. Good. Yeah, x to the 50th times x to the 50th. So anything raised to an even power is a perfect square. Y'all understand that pretty well now. Good. So the way that I would work example 1 is I'd say, hey, look, the first term, is it a perfect square? You bet your biscuits it is. Okay, it's x times x. Grove, how do you feel about the last term? It is as well. So my first check, I said, is the first term a perfect square? Check. The second check says, is the last term a perfect square? And Grove just said yes. And Grove, I believe you were going to split it up for me too. 5 and 5. Okay. Now that's where my little green list comes in handy, right? Because if that number is something like, I don't know, 361, okay, and you're asking, is that a perfect square? It's good to dadgum know that is. At least on my list, you might not. You might have to think about it. What is it again? Is that 17 squared? Oh no, that's 19 squared. You know, but at least you've got it in the memory bank. Says, oh, that's a perfect square. That's a nice number. Okay. And then here's where I really want to focus. And y'all have had enough time, so I'm gonna zoom in here just a little bit. Here's where I want to focus. That third check is so important. Okay, because this is going to be where we test to see whether or not it actually is a perfect square trinomial, okay? Not all trinomials that start with a perfect square and that end with a perfect square are perfect square trinomials, okay? Well, watch me now. Here's how I can determine. I like to circle. Everything that I do right here, I do every time I'm factoring a PST. I split the first term, split the last term, and then I go through and I start circling, okay? So circle the square root of the first term, circle the square root of the last term, multiply those two together. Okay. Multiply those two together. What do we get? 5x. If I double that, and that's what this middle term is, then check, check, Check. It's a PST. So 5x doubled is indeed 10x. So that's a perfect square trinomial. And as I fill in the template, a plus b quantity squared or a minus b quantity squared, the sign in the middle will tell me what my sign of my binomial should be. So if you've circled it like good little boys, all right, you get a pat on the head because now you know what your answer is. X plus 5 quantity squared. Good job, good job. So literally go through the process, split both the first and the last term, circle, circle, do your check, and then circle the sign in the middle, and that's your answer. Shall we do another one? Quentin, go with the question first.
How is it squared?
Ooh, okay, fabulous question. Great question. Okay, so what's another way of saying something squared? Something times itself. Okay, so like literally, we could have worked this. You could have said, well, wait a minute, Coach Morgan, this is an old school question. This is an easy, one of those basic trinomials where I got x squared plus 10x plus 25. Can't I just look at 1 times 25, 5 times 5, and find the pair? I'm getting down into this next example, aren't I? Find the pair that adds up to that middle term and use it. Y'all bear with me just for a sec. I'm doing something here. I thought I was doing something here. Didn't I just do Control X for cut? Oh, OneNote's not responding. I hate you, OneNote. Okay, I'm just joking, OneNote. I love you. I'll always love you. So to Quentin's question, we could treat this. Now I got a little extra space. Now we're gonna paste that back in there, and of course it's jacked up. I hate you, OneNote. Such a fickle lover. X squared plus 10x plus 25. You could say, Coach, I'm so used to looking for two factors of that last term that add up to that middle term. And couldn't I just say, oh, they're both 5, so it's x plus 5 and x plus 5? You most definitely could do that. You certainly could do that. That's that old school factoring technique for those easy trinomials. However, it's going to take a little bit extra time, especially if the number at the end is a big perfect square. But also it is, and please make a note to this effect, it is preferred that we write our answer up as x plus 5 quantity squared as opposed to x plus 5 times itself. The reason being is that later on I'm going to teach you guys, we're going to be solving equations that have perfect square trinomials in them. And one of our techniques is going to be called completing the square and using the square root method. And if I'm in the habit of listing it out as a binomial squared, that's going to make my life a lot easier. Suffice it to say, you guys need to develop that habit early now, as opposed to later on when you've already developed a bad habit. It's hard to develop a good habit. It's harder to fix a bad habit that you've already developed. You guys that play sports, you already know that. I have a bad habit when I'm playing golf and opening up the club face off the tee box. That's a bad habit that I developed from having a baseball swing all my life. And so it's hard to break a bad habit. So don't get into this bad habit here. My comment would be check for a PST first. You got your 3-point checklist. Check for a perfect square trinomial first before you try the old school easy trinomial factorization technique. Okay? Heaven forbid you, on example 2, you jump in and start doing magic method. Good night, America. That would be a mistake, wouldn't it? So like look at example 2. I'm gonna give myself plenty of room off the get-go here. Look at example 2 here with me. Have you written that one down yet? If not, go ahead and write it down. 9x squared plus 12x plus 4. And yes, I know that I could jump in and say this is magic method all the way, but that's going to be a crap load more work than I need. If I look for my bread and butter factoring techniques, if I check to see, is there a GCF? By the way, is there?
Yeah.
Well, the dump is in common between all 3 of those terms besides 1. No, there's not. What? I love you, Paul. Keep me on my toes. No, there's not a GCF. Is this the difference of 2 squares? No, it's not a binomial, Coach. So the third bread and butter factoring technique is this perfect square trinomial that we're checking. Okay, so George and Nate and Jack are going to be my check. George, how do you feel about the first requirement? Split it up. 3 what? 3x. Attaboy. And 3x. Fabulous. Okay, Nate, is the second checklist or check on my list taken care of? It's a perfect square, so we've split it up as 2 and 2. That's obvious. Okay, so 2 and 2. And oh, Jack, we get to you now. You're the most important check right here. What am I looking for here? No, not plus. Multiply these two guys together, and you get what? 6x. And then double it, and is that what's in the middle? It is what's in the middle right there, 12x. So this is a perfect square trinomial, and so we'll just run the whole row there. Joey, how does it factor out? 3x plus 2. Now I'm going to be a little bit of a picker of the nit here. Okay, let's say it's 3x plus 2 quantity squared. Okay, I know that's nitpicking, but you guys, you want when you're talking, when you're verbally communicating mathematics to someone, you don't want to sound like an ignorant boob. Okay. If you're out on a date with a young lady one day, and as oftentimes happens on romantic dates, the topic of conversation turns to algebra, and you're discussing how this great trinomial was factored out as 3x plus 2 squared. She's going to look at you like, you ignorant boob. 3x plus 2 squared is not how a trinomial would factor out. If you verbally communicate 3x plus 2 squared, that looks like 3x plus 4 to me, or at least that's what it sounds like. So we want to say what? What was the Q word I used? Quantity. Now, all of my ninth graders the last 15 years all know that's just a little pet peeve of Coach Morgan's. And so if you're in Coach Morgan's class and you want to say something like a binomial squared, you can say quantity and take care of that. And you sound so smart. And that young lady will be like, oh, this is the boy for me. And life will be good, right? Y'all can't tell I'm smiling behind my mask. Okay. Anyway, check. PST, good. Questions about example 2. All right, this should be one of our easier techniques. We like this technique a lot. I want you guys to try example 3 on your own. Try example 3 on your own. I'm going to zoom in so y'all can see a little bit better. Some high quality H2O. Remember, first thing we look for is there a GCF. Second thing we look for, is this a difference of 2 squares? Third thing we look for, is this a PST? Because that's our bread and butter factoring technique, 1, 2, 3 in a row. There is no GCF. There's 3 terms instead of 2 terms, so we look to see is it a PST. Let's see here. Jake is going to tell me about the first term. Okay. James, you want to tell me about the last term? 4 times 4. And Reed, what do you think, brother? Is this a PST? And if so, how do you know? I'll help you out. Reed, what's 9x times 4? Speak up. I got goobers out in the hall that are being loud. 36x. Good. Double that and you get what? 72x. Hot dang. That's what we have in the middle, so we're going to use that sign. And how did you guys write your answer up? What was your answer? Yell it out. Go ahead. I love y'all so much. Y'all threw that quantity in there to make me so happy. Oh, just warms my heart. There are some curveballs that get thrown at us. So some like weird problems we'll look at real quickly. Here's one that just happens to have a couple of variables in it. Do you remember what we said do when there's a couple of variables, Joey? Yeah, just temporarily ignore the second variable. So like I'd split this one up as 6x squared and 6x squared. I'd split this one up as 7 times 7. Now technically I think I'm with it enough to say 7y and 7y. I'm good like that. Hope you are too. We look here. What's 6 times 7? 42 doubled is 84. And it's got an x squared and a y, so we're straight up 6x squared plus 7y. So don't be scared, even if it's got two variables in it. You guys can handle the two variable ones, right? Not too bad of a curveball. Tiago. 9x minus 4 quantity squared. Because we were subtracting at the very beginning in the middle. Go back and look at your templates and remember that if there's a plus sign in the middle, then you're going to have a plus sign in your answer. If there's a minus sign in the middle, you're going to have a minus sign in your answer. All right, and hey, look, our time is up. It is Friday. Have a wonderful weekend. Be healthy, be safe, and live Jesus in our hearts. Thank you so much, fellas. I'll see y'all on Monday. And you boys online, y'all take care, be safe, and thanks again. See you guys. Thanks again.